Okay, we have two cables. They're supported by a 1500 pound weight as shown. Find the tension in each cable. So I call the tension in this cable L, and I call the tension in this cable R. So I want to solve along the vertical line. So this L along the vertical line would be L cosine 65. And this R along the vertical would be R cosine 54. These two tensions are pointing upward while the weight is pointing downward. So as you see along the vertical, I have L cosine 65 plus R cosine 54. They're pointing both upward, and they're equal to 1500 pointing downward. Or you can say just minus 1500, since you know the positive direction is upward, and then you can move the 1500 to the right and make it positive. So that would be my first equation. My second equation would be to solve the tensions or the weights along the horizontal axes. As you see along the horizontal, L sine 65, because that's the opposite side, it would be L sine 65, R sine 54. Now each one now is pointing in a different direction. That's why they are equal. Okay, so you can either solve in one direction and then move one of them to the right to make it positive. So that would be my second equation. There is no component of the 1500 along the horizontal because it's pointing vertically down. So I can solve for L here. I can divide both sides by sine 65, and I get L as R sine 54 over sine 65. As you see here, I'm using the substitution method. So I'm going to substitute L back in equation 1, and I'm going to get this whole equation after I substitute L equals R sine 54 sine 65 here in this equation. Now you notice that the only variable here is R. So cosine 65 over sine 65 is nothing but cotangent 65. So I took R as a common factor, and then from the first term I'm left with sine 54 cotangent 65, and from the second term I'm left with only cosine 54, and they're both equal to 1500. So all I need to do, divide both sides by the coefficient, and the coefficient in this case is the whole cosine 54 cotangent 65 plus cosine 54. Okay, so now my R becomes equal to 1500 over the whole denominator and end up with 1554 point something, but I need to round to the nearest pound. So if you round to the nearest pound, you end up with 1554 pounds. To find L, go back to the second equation, substitute the value of R, which is 1554 sine 54 over sine 65, and you end up with 1387. So L, the tension L is 1387, and the tension R is 1554. And notice the smaller the angle, the bigger the tension. The bigger the angle, the smaller the tension.